Hi class. In last lecture we talked about array implementation of stacks. In this lecture we are going to see linked list implementation of stacks. And here is some example. You can see a linked list here. And here's your top, which is front of linked list, and some other values. So when we work with linked list, we can only, linked list of stacks. We can only access top just like we did with array. But in this case, the top is front value, front node of linked list. And just let's code, let's write some program to implement stacks with linked list. We will do something very similar what we did with arrays, but this time it's linked list. So I'm going to write a program, but first remember, when we work with linked list, we always need our node class, always. So first thing to do, I'm going to write a node class. And basically we can use what we already have, just be careful with value if you are using string or integers or any other data type. We already have done this before, but I'm just going to do it very quick. So string value, this is value to be stored in node. And you remember, linked list consists of two parts: value, which is data or info, whatever you prefer to call it, and node next, which is connection to the next node or reference. And we need couple constructors here. Public node with parameter of string value, and let's say this value, this value, this. If you don't remember constructors for some reason or objects, please revisit chapter 6 of your textbook. It's Java 1 material. And if you don't remember something, just I recommend to read this chapter again. Second constructor, public node, which will take string value as a parameter and node next. This value is value and this next is next. So we are done. It's the same what we have done before. So we are done with our node class. Now I'm going to create a class for my stack. So it's going to be public class my stack linked list. So this stands for linked list, so you will not get confused. And of course what we need here is node top, because remember we need to keep track of top, and we are going to have some constructor here. Sorry, constructor, just public. So if you remember, in arrays implementation, we had also size for our stack. Why do we not have size here? We don't need this because remember, its advantage of linked list, it's dynamic. Whatever, how many, it doesn't matter how many values we put or elements we put in our list, we don't need to resize it, we don't care about size. So for the constructor, we will assign a top to the null. So now I'm going to create isEmpty method. So the isEmpty method, you remember it's the same purpose why we did it for arrays. If you haven't watched a video on stack with array implementation, please watch it. So the isEmpty method checks for an empty stack, and it returns true if stack is empty and false otherwise. And we know it's going to be public, and return type is going to be Boolean, and name of the method, which is empty. So how do we check if it's empty or not? It's simple. We just return top equals null. So what it means, if top is null, it means the stack is empty. And of course, if it's not null, the stack is not empty. Let's create tester for this class. Public class my stack linked list tester, and of course method header for main method, public static void main string args. So now we do the same what we did for arrays. My stack, sorry, it's capital letter. So name of your class, which is my stack linked list. Oops. My stack linked list, and I will name it stack. S stands for stack. And just like always, we create objects. New my stack linked list. And now I'm going to check if it's empty or not. System out println is empty plus name of my of my stack, and name of the method is empty. Let's see, compile, run is empty, true. So good. So again, we know when if top is null, it means stack is empty. So now let's write another method to push some elements to the stack. So again, the push method pushes a value into stack. Actually, I will put onto the top of the stack. So the same what we did with array implementation, but we just need to know what's the top. I mean, how we can insert it. And it's going to take parameter, which is the value to push onto the stack. So public void because I'm not going to return anything, I'm just going to push, and it's going to take string as a parameter because that's exactly what I want to push into my stack. That's exactly the value I want to push. So, and you already know how you push, how you add element to the front of linked list. It was in your lecture, last lecture, it was in your assignment. Remember in the lecture we had two cases, if the stack is empty or if it's not empty. And this time we want to push always at the front. So what do we do? How do we do this? Easy, just top, new node, and parameters s and top. That's how we regularly usually add value to the front of the list. Just like a regular linked list. And that's it for this method. We are done. We don't need to increase the size because that's why we love linked list, because the size it's not fixed. The size is not fixed. It's dynamically increasing when you push elements, right? So that's it for the push method. And again, what happens here? Our top is null, right? So top equals new node. That's how you create new node. With parameters, your string and top. That's where you specify where you want to add a value. So let's check how it works. Go to the tester class. So I'm going to push, let's do EPCC again. And after I push, I'm going to check if it's empty or not again. So again, stacks might sound complicated, but it's actually easier. It's easier than a regular linked list or regular array, because you always know how to work with just with one element, basically. So is empty true and in a PCC is empty false. Now let's write a pick method that will return top element of linked list. So the pick method returns top element of the stack, and it doesn't take any parameters because it's just top. We cannot do too much, but it returns value of the top element of the stack. And of course, what's going to happen if we are going to access some value which doesn't exist? It's going to crash. That's why our method should throw empty stack exception, just like we did with arrays. And let's take a look at this method. Of course, we need public string because we are going to return string, which is value at the top. And name is pick. And of course, we need to throw empty stack exception. We are going to have if statement to check if it's empty. And if it's empty, just like what we did with arrays, we are going to throw new empty stack exception. And here, like, oops, it is empty. Some drama here. Okay, but if it's not empty, how we can pick? Let's say else return top that value. You remember how we access value at linked list? Okay, so top that value, just like how would we access it with a regular linked list. Nothing new here. And just let's test it. System out println pick. What is the top? But before we do this, Let's go back. And you can see we use empty stack exception. Of course, I created it for different videos, so I have it, right? But if you do not have it, you will need to create it. And I was explaining this in video in stacks using arrays. Just we need to remember that we need try and catch statement. So that's how we handle our exception, right? Okay, and now let's pick compile, run. What is the top EPCC? Yeah, let's push couple more. Like Java and CS. Compile, run. What's the top? CS. Why? Because we pushed it the last one. That's why we want, when we pick, it's going to give us the last one, what we pushed. So that's what we call top. First we placed this, and then this, and then this. So it's top of our stack, right? And that's what we were expecting. And the last method which we are going to write is pop. So the pop method or removes top value of the stack, and it returns value was removed. And of course we still need to throw an exception in case the stack is empty. So it's going to be public string. Why string? Because it's what we want to remove, and not remove but return what was removed. No parameters because we don't have any options but top. So we don't need to specify anything. And of course we are going to throw the same exception in case it's empty. If it's empty, we will say no, it's empty, you cannot remove what it doesn't exist. Okay, so else I will just create string r, which I'm going to return, or you can just return it something like this. So top value top value. So how do we delete? How we can remove it? It's exactly the same what we do for regular linked list. Top dot next. That's exactly how we remove front value, right? And that's it for pop method. Oops. So our top becomes top.next. That's how we update our top. So recompile. Oh, I forgot to return. Return R. Compile. Compile. Okay. Let's remove it. Remove top. So we removed CS. If I call this method again, it's going to remove Java. Let's see. Compile, run, remove top, Java. Then I'm going to call this method again and it's going to remove EPCC. Compile, run, remove EPCC. So it's very important to understand that there's not much difference between linked list implementation of Stack and regular linked list. The only difference is that this time it's limited. You cannot access anything you want, you cannot do anything you want, you only can work with the top. And in the linked list, it means you only can work with front of your list. Of course, you can push and it's going to be always front also. And the same with arrays, implementation of Stack. Every time you work, for example, I can ask any method, but you never can touch anything what inside your stack. Only top, only top. And that's the most important thing to understand. And that's it for this lecture. Just let me know if you have any questions about stacks in general or linked list or array. And of course, if you want to work with integers or doubles, you need to change your constructor here. And yeah. Let me know if you have any questions.